Presentation is about data ingestion strategies from Apache NiFi into Apache Iceberg. Additionally, if you're new to Apache Iceberg or Apache NiFi, this is will likely be a good introduction to both those to get you started to move down different directions. My name is Lester Martin. I work at Starburst. I'm a developer advocate there. Starburst is the Trino company, and very specifically for this talk, I've spent some time, maybe 3 years, with Apache Iceberg, primarily with Trino, and maybe about 8 years with Apache NiFi. So, what is this Iceberg system? Well, Iceberg is in the data lake analytics space. It's a high performance data lake table format, as they're often referred to. If you've heard of something like Hive, same kind of thing. And its real big pushing point is we're looking for making sure we have interoperability with a bunch of different processing engines actually working against the same table at the same time. Very powerful stuff. And if you're not familiar with data lake analytics in general, what we're talking about is systems where data lives in files over in something like an object store, like an S3 bucket, maybe something like a little older, like a HDFS as well. But generally speaking, we say a data lake or object store. Now, what are some of the features that we have in Iceberg? Well, the database people think, sure, don't we? Doesn't everyone have this? Data lakes didn't always have this, but we definitely have CRUD operations, including that super powerful merge statement, and we get that with ACID compliant transactions. So it happened or didn't happen. We have concurrency checks, all that kind of important stuff. I would say that today we only do single statement commands, and it's an auto commit kind of strategy, but there is some work going on in the community about multi-statement commands across multi-tables, all that good stuff. Iceberg will let you change your table via an alter, but unlike a lot of the history and data lakes, we got to kind of make sure all the data lined up nicely. It's going to make sure it can do things that make sense, that work, and not create all kinds of crazy problems. And data lakes support this concept called partitioning, where we use folders that are aligned maybe to columns, so that are highly used in where clauses. That help us look at less and less data. Iceberg allows us to actually evolve and change the partitioning definitions as well for live tables as they're going. Continue to change that. And I wouldn't change it all the time, but it is a really awesome feature. Every time we do some of these changes, content, every time we add something or anytime those transactions occur, we change the structure up, we're going to build a new snapshot out there. And what those do, these versions, these snapshots, we can actually use them to query. We can look back in time. Hey, show me what this table looked like an hour ago, or we can say, show me what this table looked like this specific version ago. We have branching and tagging a lot like you think about in software. That might make a little bit of sense to some of us in our data, and we absolutely could roll back to a point in time. Very useful, especially in debugging, especially in development. We're trying to figure things out, but a really powerful feature in production should you need it. Now, the architecture of Apache Iceberg is really about the data and the metadata, and we definitely do not have time to try to explain all this. What I really want to point out is that Iceberg brings, just like some of the other data lake formats, like Delta, for example, brings the metadata out of the historical kind of catalog or database, and it puts them in files, metadata files, and they live out there alongside the data in the object store, in the data lake repository itself. Pretty powerful stuff. The only consequence I would say about that, gives us all those awesome features, but it does require some maintenance. Now, some of this maintenance is stuff we did always, rebuild statistics, etc. But and then compaction. This has always been an issue in big data systems that are file-based. People end up often with little small files, and we need to rebuild them as bigger. So I don't want to go into all the data maintenance activities here. If you're familiar with them, great. If you're not, just accept that there is some work that has to happen, and I'll address that, how we might tackle that as we go along. So let's do a quick demo, keep it kind of easy and going. And I'm going to run over here, and I'm going to create a table right here called Pokemon Spawns. Now, Pokemon Spawns is a table that I'm going to store Pokemon Go games when the Pokemon monsters are actually spawning. They're created, they show up, and people can start chasing after them. Unfortunately, my little free cluster quiesces about every 5 minutes, so I didn't keep it alive. Probably should have, but it's going to be spun up here in a second. And if you look kind of closely, and if you look at the data I'm about to add to it, it's really got a bunch of lat longs and times, and at the end of the day, what kind of Pokemon itself surface. So if you're familiar with the game, awesome. If you're not, that's okay. It's just a set of data as we go along. All right, it finished. So I'm going to do 2 quick insert statements, and then I'm going to do a couple. I'm going to run another statement. So I'm going to say insert 3 records, insert 3 other records. We're going to look, and of course we're going to find 6 rows. There we are, Weedles and Diglets and all kinds of fun stuff, piggies and everyone. And really what I want to just take a moment here and say, look, that created actually 3 snapshots. It created one when we created the table, the second when we added 3 records, the third when we added 3 more records. Again, we're not going to master Iceberg in 5 minutes, but I want to give you a flare of what's going on. Now, I'm going to slide back to the presentation. Oh, let me show one more thing. And that stuff does live out there on the object store. So I'm going to go to my little S3 bucket that I got stood up, and I have a folder here called NiFi ingest. That's my schema, and there we are, Pokemon spawns. That's the table, and inside of there, as I promised you, there's 2 folders. One's data, that's the actual data files. There's 2 of those. One has 3 records, another one has 3 records, and if I went back up, there's a metadata folder, and you can already see I got about 12 files in there. These are avros and JSON files. That was that big architectural diagram. There's things that happen there. Don't be scared about that. In fact, there'll be quite a few in there in a hurry. But again, the data maintenance, it's not a bad thing. It's a good thing, but it is a thing we have to be aware of as we go along. All right, let's slide back to the presentation. We're about 7 minutes in. We're looking good. And let's talk about, I believe we're going to talk about NiFi. Sure. Let's transition to our other Apache project. And, there's some splash on the homepage. What's NiFi? Well, it's a lot of things, but for today, we're going to keep it simple. It's a low to no code data flow or data pipeline creation tool. Has bits of ETL, has bits of orchestration, lots and lots of things. But at the end of the day, it's a tool about lifting data from one place and delivering it somewhere else, and then whatever we need to do along the journey in the middle. If you're unfamiliar with this, I got a nice link to tutorial at the bottom. At the end, I'll show you how to find these slides. They'll be in the deck as well. And we're talking about data ingest. So you might ask yourself, hey, Lester, are we talking about batch data, grabbing files? We're talking about grabbing messages off a topic or something? Yeah, we're talking about both. And to be honest, that's not the conversation today, because just like maybe Spark with Spark Streaming can handle just adjusting where am I pulling information from? The rest of the processing is going to be the same. Same thing here. So I'm going to extract away where I'm grabbing this data and then show you some strategies as we go on. So lots and lots of good interoperabilities there. You're going to see pretty quickly when I get in the tool, it's just a drag and drop model. Drag off the toolbar a processor and configure that processor. Grab another processor, configure it, make a connection between the two so data flow from process to process. And it can get a lot more elaborate than A to B and B to C, but many of what things we'll do today are pretty linear in nature. Lots and lots and lots, hundreds of processors available today, not just inputs and outputs, but all kinds of cleanup, enrichments, transformations, decisioning, that kind of good stuff. And even those connections themselves are backed themselves by durable queues. The queues are only there for the purpose of getting the data into the next flow. They're not there for long. I'm not trying to replace something like a Kafka, of course not. And I want to just take a moment and say NiFi is a little bit unique because in addition to being a development environment, it's also tackles the rest of the classical development lifecycle. So there's no compile and build. Things are already there. Now you could build your own processors, and sometimes there's good reasons to. Arguably, I would say find a reason to see if it can work with the processors that exist before you go build one, but at least the first place. Deployment, everything's already there in the system. There's nothing to move and shift, but likely you're going to have production environments and non-production environments, of course. So I do not want to suggest that that's not a great idea. Runtime. This is the runtime. That thing you're going to drag and drop on. Every processor in there is independently startable, stoppable via the command line. Via the GUI or via REST API. And this thing can scale really, really, really big. 1,000+ nodes. So I know Cloudera did a lot of scaling out a couple years ago and published those results that were pretty impressive. Monitoring and boarding. It's going to give you right there in each one of the components. You're going to see a lot of information that's helping you know how it's doing, how it's scaling, how many processors, and all this kind of stuff is taken advantage of, including those queues, what's in there, how much data is flowing through at that particular moment. And if you really want to look behind the glass, you can see the data that's in all those different queues. You can see the history or the lineage of what's happened to it along the way, what's going to happen to it, and should something bad happen, which it may probably do on our demo, you know how that goes. Just hover over that little red box and all kinds of information about the logs are going on. So I just want to take a moment and say NiFi is a little different than probably a lot of the classical environments you do, and I know we all hate and love low-code, no-code tools. I know some people are definitely each one of those camps, but it's generally speaking a low-code, no-code drag and drop kind of tool. So let's see a quick demo of what we're talking about here. Let's show you that environment. So I'm going to move over to here, and I'm going to go. I've already logged into Apache NiFi, and here we are. I am on a canvas. I have a toolbar. I can drag and drop processors like I want to get something from Mongo. I just type MongoDB and start looking in here. Hey, get Mongo, put Mongo. These are kind of classic features. If I did a get Mongo, guess what? It's going to drop it on the palette, double click. It's going to ask for things like, tell me what you're talking about. Tell me about the query. What are you trying to get? Pretty normal sounding kind of things. Now I'm going to get rid of that. I already built us a little set of demos here, and I built us a simple flow. And what you see as I zoom out is it has about 1, 2, 3, 4, 5, 6, 7, 8, something like that processors. But what it's going to do, and I'll just give you the quick rundown, it's actually got a pair of processors at first that are going to go poll a location. That location's is right over here. Let me see if I cleaned it up. I did not, but that's okay. So I got something in a folder called ingest, and I just happen to have another folder right here called egress where I'm going to move things to. I'm going to go find files like a zip file, and I'm going to unwind them, make sure they have the right kind of files, and then I'm going to ultimately make some decisioning on how big or small or medium-ish these things are and push them into another place. So think this is a simple data movement workflow. And don't imagine I'm dropping them in the same folder on my laptop. Imagine I went from S3 to ADSL or something like that. All right, so without explaining it 100,000%, I'm just going to start kicking off. This thing went and looked for folders of files. It found one. This thing said, okay, I actually go get the file. I refresh it again. And you can start all these at once. I just want to kind of walk through it. This is a zip file. If I looked in that folder, I'll save that for a minute. Quick processor that just says, hey, make sure I notice the MIME type. And then ultimately, I'm going to run one called unpack, do an unzip. So I'm going to pause there and show you a few things, like I can look into these queues. And this queue says, hey, that zip file I had a minute ago now is 43 other files. These are the works of Shakespeare himself. Good stuff in there. If you really, really wanted to look in there, you could. You can say, hey, look, show me the details of each one of these. There's the concepts like attributes, little kind of overhead things like a wrapper, and including, hey, show me the details in there. Now, these are text files. So let's take a look at them. There they are. Characters in the place, so on, so on, and so forth. All right, so this thing found a file, broke it apart to a bunch of other things, and then we had some logic that said, make sure we're only grabbing the text file. So there's a little bit of logic I wrote in here with some concept called expression language that just looked at the file format extension and said, hey, separate them. So it actually found one thing that's not a text file. Take a quick peek at that one real fast. And I'll do the shortcut to the content, view the content. I'm going to toggle this to an image because I know it is. Oh, it's Will Shakespeare. Fair enough. Not so important. We can clean that guy up. I'll just leave him in there for now. And this last guy, I guess I'll look at it before I do anything. It's just got a bit of code in here that's going to say, hey, take a look. Using this language called expression language. It's very JavaScript to Java to, it's its own little animal. If I can get the, well, a little more patience here, Lester. There we go. There we go. It's just basically going to look at the file size. If it's under 75K, it's going to call it small. If it's under 150K, it's medium, and everything else we call large, and it's actually just going to create an attribute. You might have noticed those elements had wrapper attributes. So I'm going to add one of those attributes to all those them individually. So if I run this will just move 42 here to 43 there. And then ultimately what I'm going to do is use that when I go up push this file, and I'm going to use it right here in my directory. I'm going to say, hey, put it in this folder as egress, but pick a subfolder based on that little individual elements activity declaration there. So I'll go ahead and run that as well. And if we toggle back over here, we have a flow done. I'll do a quick tree one more time. There we go. We have a few larges, a lot of mediums, and a few small. We're not going to take the time to go look at those file sizes, but that's what it's doing. So super simple flow, nothing all that magical per se, but it gave us a deal there. I'm going to hit stop everything here just so that's out of the way. Take a look at my time, about 15 minutes in. Let's get a little further. Okay, I want to take a moment and say NiFi has actually been embraced by other folks. It's in use of somewhere between 8 and 10,000 organizations around the globe use this thing for in some small or large amount. Hortonworks, I was lucky enough to be there when we acquired this company that was supporting NiFi. We ultimately changed it to Hortonworks Dataflow. We merged, became Cloudera Dataflow. And 2 weeks ago, Snowflake. 2 weeks ago, Snowflake announced that they have a product called Snowflake OpenFlow. Well, it's NiFi. It sits on top of that. In fact, I was working at that company last summer for a few months and helping them get this thing looking exciting to folks like that. All right, so we're making it 16 minutes in, talking about those ingestion strategies. In the big data lake kind of analytics world, often we have a lot of our data sets, especially if our really large ones, are immutable data sets, things that have a timestamp associated with them, a call or transaction, etc. And often these tables are very append only, and they offer us some opportunities to go really fast and do really neat things and don't give us a lot of grief. And I would say in the NiFi world, if you knew enough about the naming conventions, you might ask, hey, is there a put Iceberg processor? And the short answer is yes and no. I'll tell you the yes and no in just a second, but ultimately, what is that processor doing? It's saying, hey, regardless of where these records or files are coming from batch or from streaming systems, we're going to take them all, and you can have all kinds of settings, how big, how small, how often, all that good stuff. But basically, we're going to micro batch them up. We're going to build them into file formats, and in fact, what it's doing is actually going to convert however the data came in and convert it into the file format that specific table has previously chosen. So it needs to be aware of all that. And then it's just going to drop those out in the data lake, and then Iceberg has an API that says, hey, add these files to the metadata. It creates another snapshot. So it sounds like a good thing. Problem is, well, with CDF, it's there. Amazingly, while it can put on things like S3, it really kind of works with CDP, the Hadoop platform, Snowflake. Know these guys well. Built a processor called Put Iceberg Table. Pretty limited, only Parquet, only Polaris, catalog. But at the end of the day, the problem is it's not open source. And that's not a problem, but it may be a problem. For us, today it's a problem because I want to do it all with Apache software. So really what we're going to say is tactically what we need to do nowadays is just emulate those same steps. And it really is just a few boxes, a few drag and drops, as I'll show you. And then arguably somebody ought to go back, it's an open source project, and enhance, bring up, put Iceberg to par so it can work in a variety of situations because it's still valid. Is that going to be you? Is it going to be me? Somebody needs to do that. So let's see that emulating the put Iceberg behavior. All right, so let me see. I got something very similar here. CD, CD, box, yep, CD to NiFi, yep, perfect. I got a tree here. So I got a folder here. I have a ingest only folder here because what are we going to do? Well, we are going to assume someone's dropping the files. I'm going to prime it more of a batch, but easy enough to adapt this to Kafka or something. And I'm going to throw folders into that ingest, a different ingest folder. And I'm going to do much like you saw before. And let's get into it. And those are just CSV records that look like the table that we saw earlier. So I'm gonna go back to the top. I got this guy, this get data, and I just wanna get it started, then I'm gonna get out of it. So I'm gonna drill into him, make sure my state's all cleared out. Yep. And I'm gonna make sure it's running and not find anything. Nothing's there, right? Okay, great. Now I'm gonna run all the rest of these. These are just gonna ultimately go get some data. So this is emulating my start everything. This is emulating my, doesn't matter where it came from, it's coming out. And then on the left here, I have another process group I call put iceberg sim or simulation. So do what the put iceberg is doing. And what put iceberg is doing, let me see if we can get some records in there. Okay, no records are showing up. Let's go ahead and throw some data in there. I'm gonna do a copy of Pokemon tiny, .csv into /folders ingest. So there we go. Someone dropped some data, or someone put some data into a Kafka message queue, etc. Ultimately, let me see if I can see those records. Refresh. Well, eventually it's going to show up here, I believe. Let me double check, make sure. Yeah, everything's running there. All right, let's see if it showed up yet. There we go. I got some records queued up. So let's go look at this stuff. Go to the queue. This is a clump of information. And if I look in there and I just look at the contents of that, guess what? It looks like, if you remember that table, a bunch of lat longs and the name of the Pokemon, etc. So this is a burst of 5 records, nothing magical. Now, I think it will probably be helpful if we go over here, and because my cluster on Trino is stopped again, so I'm gonna start it back up. All right, so I did that on the side. And really what I want to show is, what do we need to do? Well, that table was backed by Avro files, if you remember. So I got to convert this thing to Avro. That's all that did. And then I need, and you can look at that too. It's got a viewer that can see Avro files. I guess we can take a moment and glance at that. List queue. I'll just go straight to the view content and skip all the other stuff. Yep, it's converted those CSVs to Avro. Why? Because we're just going to kind of force them into the system. So they need to be in the file format that table ultimately can reference. We need to go put it somewhere. So I'm throwing it in S3. I'm throwing it maybe right over here. Galaxy, the add file strategy, Pokemon. There we go. There's a file. Good for us. That's really what we wanted for the moment in time. And then ultimately I want to run some SQL. I guess I can run it and then show you what it says. So run, start, boom, off and running. And it looks like it already finished, which is awesome. Maybe those are from earlier. Yeah, there we go. So I'm going to run my SQL. What does it say? View configs. All it really said was, hey, use that API. Now I'm calling Trino. When you do an API, generally speaking, I might call an engine and say, hey, use that API. You could write that as a processor. That's what the folks at Snowflake did, and that's pretty cool stuff too. But this was pretty easy. I just signaled Trino and said, hey, Trino, in that table, add the files in this location. And I made it kind of simple, just one simple file right now. You could have a whole bunch of files at once. And that finished, and it said it all done. And there were 4 records in there. So if we go over to our query editor, I hope that there were 6 before, and I run select again. I'm hoping I see 10, 11. That meant there was 5 records in there. We'll just leave it at that. Yeah, it was 5. My next one had 10. All right, so there we go. I got 11 records in there. So what I want to do is simply go back and add another file in there. So I want to copy Pokemon tiny2 into that same folder, folders, ingest. And if all goes well, no such file or directory. Oops. Folders. Yeah, that's all I missed. The S. Folders. Just. If all goes well, I'm at 25 after. Need to go a little faster. Then I'm going to refresh this. Hopefully, here, we'll just go look. See if this worked. It's going to have. This next one has 10 files, so it should jump up at about 21. If it ever notices it and gets there. Yeah, there they are. 21 records. And we'll do it one last time with a bigger file. Copy Pokemon big, and that has about, I think, 30,000 or 300, I think 300,000 more records. So it'll take a moment for all that to happen. Take it, pull it down, convert it from CSV to Avro, push the file to S3, which we can kind of go look out here and refresh this, because if it's there, it'll be done. Not quite there yet. Any second, it'll show up. And as soon as it shows up, the ad's going to run, and after the ad runs, we'll automatically have whatever that is, 300,000 or so. So we'll run over here, and this time we'll just do a count instead of a select all, and see if they showed up in there. Count says 21, so they haven't made it yet. So we're gonna go ahead and pretend they're gonna make it. We'll come back because I want to keep this thing moving here, and I'm gonna look at the slides and I'm gonna come right back. Nothing wrong with a live demo on my laptop here. All right, slides. All right, so we'll go back and verify it in a second, but the problems or the caveats or the concerns about this strategy is that not only does the data engineer need to be very explicit about the file format that the table needs, and it also has to do that conversion if needed, if it wasn't already in that file format on the NiFi cluster. Can scale, can tackle that, but maybe you might want to have a very lightweight NiFi cluster and put a lot of that burden on the compute engine to do the conversions. So we're tackling it here. Someone's got to do it. Different approaches there, but very likely the data engineer is not going to be able to tackle some of the more advanced features that are maybe have been set up by the person who created the table: partition, sorting, bucketing, bloom filters, all that kind of good stuff. So let's see if it finished, because I'd like to make sure that happened before I moved on. Query editor, I'm just going to run here. We'll see if that made it. Yay, there's 3 files there. I'm going to run the count again. Should be 300 and some there we go, 314,000. So they are there. It all worked. That's a strategy that worked. Now, the question might be, is there something else we can do? And there is. And it's just a real simple process that arguably I did a presentation on this at Hadoop World 12 years ago. It's a pretty normal old school pattern, which just says, you know what, let those records come in from file formats. From file loaders, from Kafka, whatever it is, and do something like what we talked about, but let's just not convert those. Let's not worry about converting, getting the file formats, or worrying about the partitions, all that kind of stuff. Let's just throw them on the data lake, build a quick Hive table around that, something we're going to use briefly, an external table, and then just do an insert into statement. Hey, insert into my big table the contents from this little small table I just created for this purpose. And as soon as that happens, it'll be transactional, all those activities at once, hundreds of thousands, billions, or tens, whatever it is. And then just throw away that short-lived table and just keep doing this. It's very lightweight, very fast, and works good. And many of those constraints I mentioned aren't going to happen anymore. So let's go and see that run. And I probably won't have as much time to dissect it all. So let's at least just run it. I am looking for this. I'm looking for this, and I'm going to go ahead and shut this whole guy down here, stop all this, go back up one. Now, I want this thing to run the same information one more time. So a few things. I need to probably go clear out rm./folders ingest slat all those. Yep. Okay, cool. Tree. Good. Okay, that didn't do what I wanted it to do. And that's fine. And we're running out of time, so what we'll do is let all 3 of those files are going to be there at once. That's fine. That actually would be pretty good. So I'm going to drill into him, and I'm going to go to the tippity top because I need to reprime it. It remembers it saw all those files, so I'm just going to stop him and clear its state out that remembers all that stuff. So when it runs again, start it off, run, that ultimately we're going to see showing up way down in here. Probably 3 files will show up in there. 6 are queued. Why 6? That's a good statement. Let's list those while we got a moment. I think what's going to happen is, yep, they're in there twice. So they already flowed through previously, and that's okay. We're going to duplicate everything. We're going to run about 600,000 things in there. We're going to do it across about 6 tables. And I'm going to run it all, and I'm going to go then just tell you what's happening so we can just see everything run. So net, what are we really going to do? I'm going to stage those files as I get them, because remember, message queue or files, we're still collapsing those based on time, based on size. We have a lot of options in NiFi about how much is enough, how long is too long, all that good stuff. I'm going to shove them out on over here on the S3 system. I have a different folder called NiFi ephemeral tables, And there we go. I'm creating these folders that have some data, and these folders are actually being used to create tables. So let's see if we can see that. Meaning what? So we're loading those there, and I'm keeping track of those. And then for every bulk of those that I put together in a folder, I'm going to run 3 quick statements. I'm just going to hover over it this time. I'm going to create a table based on some nasty words, UUIDs and stuff, so it looks kind of ugly. And I'm going to point it to that location. Then I'm going to fire off a quick insert into my big table, select all from that temp table. And when that thing finishes, I'm going to unwind it and just get rid of the temp table. And then ultimately, anything goes wrong, I'll kick it out. I can research that good stuff. And then I can ultimately decide, unlike the other strategy, when those files go in, they're going to be whatever the table eventually needs to do with them. They belong to that table. This model, those files don't, and that might be good. You might actually want to hang on to those separately in a different manner. In this case, I'm just going to go ahead and delete them just to keep clean up after myself. So it looks like everything ran through. If that's true, I'm going to go back and run. We have a 313. If I run it again, I think I'm at close to 1 million because I had 300,000. Then I did another there we go, another 300,000 and so on. There we go. Got 942,000 items in there. All right, I'm looking at my watch. We're doing great. We're at 31. I need to be done pretty quick here for some Q&A. So why don't I transition back and see what else I wanted to share with you guys here. Okay, easy breezy. Did the ephemeral strategy, and then I said earlier, pinned only is a great strategy. There are going to be plenty of times we need to do synchronization, catching a table up to what it is somewhere else, some source to target kind of model. You can get very sophisticated with change data capture and type 2 strategies and all that, but it is fair to say, especially where we're reproducing something else, oftentimes those environments, many of those tables aren't very big, millions, tens of millions or more records still isn't very big. And the old KISS principle of what if I could just, kill and fill it? What if I could just replace it once it's ready? Just do some naming swaps, right? Drop the table there and just quickly rename the one you stood up as the replacement. And that could work for a lot of things. It's not the most fun or exciting. It's very simple. But I just always want to make sure I point out that sometimes not every problem needs a big hammer. Sometimes just a little wet wipe and we're kind of done. And then my slide might be like, are you sure? I'm really saying, hey, guess what? Regardless of where you got that list of deltas, so from a formal CDC process external to NiFi, NiFi can be a CDC engine itself on some databases, etc. But ultimately, you're getting a list of changes, inserts, updates, deletes. That's it. And that's a great use of the merge command. If you're not familiar with that, it's a way to say merge this source into this target. Here's how we do the matching. Here's what's an insert, an update, and a delete. And all we have to do is take that same processor I did and change that middle one from an insert into a merge. And same thing. It's all going to be one big transaction that happens. All of it did or didn't happen. And then we can bail out and move on. And if it didn't happen, it blew up, we still have all that table right there waiting for us to kind of do. So the reference there was Fred Flintstone at quitting time at the end of the day, sliding off his dinosaur. The good news is, last thing I want to mention is we talked about that table maintenance problems. Truth is, one approach, there's many approaches, but a pretty common approach people are tackling right now is just owning those, orchestrate those activities of the really, really, really largest, biggest, high volume, high velocity tables. I would say bake it into your pipeline itself. You'll know better when to make sense, but generally speaking, this strategy right here is saying, hey, maybe at 3 a.m, do these tasks. Absolutely, we can just run a SQL statement as something like Trino, let him own this. You need an engine to interact with. You can't do those compactions yourself in NiFi, so we're just going to trigger it and see ourselves mainly as, again, an orchestration tool. And guess what? 34 minutes into a 40-minute talk, just enough time for some Q&A when I run this for live next week on Monday. But I really do appreciate your time. Quick QR code there on the right for an Iceberg cheat sheet from my company, Starburst. If you're interested, there's my QR code again, a couple links. The one at the bottom is the GitHub project, a folder in a GitHub project where I just have the source files, this PDF, and basically things that were needed for you to, review this on your own and maybe try to reproduce some of it yourself. I appreciate your attention. Thanks for listening, and I hope you got something out of it. Bye-bye.